Welcome, everyone. Thanks for joining us. Hope you're enjoying re:Invent. My name is Rob Zernecki, and I lead the product management team for the AWS Outposts business. I'm going to be joined today by Jaya Kumar and Santiago from First Abu Dhabi Bank to tell you a little bit about how they're building and innovating and modernizing their application workloads using Outposts. I've been here with AWS for a little more than 8 years now. Really excited by what we've been doing at the edge and our continued investment. And I'm really excited to spend some time walking you through how we think about the edge and that continuum of applications and modernization. I'll make sure that we just start with a little bit of a level set to keep everyone on the same page, talk a little bit about Outposts, and then I appreciate that you all probably want to hear more from Jaya Kumar and Santiago than just me about how they're using Outposts at First Abu Dhabi Bank. We'll get a little bit deeper under the covers on what we've been doing with Outposts and at the edge over the last year or so, where we're looking into for 2023, and also to talk about a couple of more customer use cases, including a really exciting one from Amazon.com themselves. So customers face challenges building a single set of solutions that can be deployed and operated anywhere across both the hybrid and their edge environments. And without a common developer experience on-prem and at the edge, it can be really slow and challenging to build and deploy, costly to operate in both manpower and dollars due to that discontinuity in capabilities and experience. There's so many applications that hybrid cloud supports today, along with edge services. And we find that many of them fall into 4 primary use cases. And the first is low latency, that physics gets in the way, if you will. Having the ability to capture, process, and make real-time, quick decisions where the data is incredibly important to some customers and their applications. Next is local data processing. Customers want to run these data-intensive workloads near where their data is. They're used to increase speed and efficiency, to help manage costs. For example, looking at data and making real-time decisions in manufacturing facilities. Reduce the data volume locally before transporting that data into the cloud or wherever their data repository is for preservation and archiving. The third is data residency. A great example is FanDuel, who must meet these stringent local compliance requirements, or other customers with national data sovereignty regulations, so that data must reside either where it's created, within the boundaries of the country, sometimes within a specific facility that's dictated by a regulation or a private contract. And they appreciate the ability to use consistent cloud-native tools while also satisfying these regulations that are so critical to their business. Finally, there's the modernization and migration aspect of these workloads. Wherever you're operating, whether it's a sports stadium, a factory floor, a container ship, customers want to extend that modernization, the benefits of using the cloud, everywhere their applications are deployed. It allows them to take that modern approach and bring more value to their data by using a cloud-centric operational model. Now today, customers tell us they want to use AWS for a growing range of these applications and bring those services wherever their workloads require. They want to deliver the best experience for their customers and provide the best tools for their developers. And one way that we at AWS are helping customers accomplish these goals is by extending the AWS value proposition from our regions where we started to our metro areas with services such as local zones and wavelength zones, and all the way onto customer premises with Outpost racks and servers, and even beyond that with our Snow family and our suite of IoT services. In short, we're taking that core AWS value, our services, our APIs, our operational tooling, and best practices, and we're trying to bring those everywhere customers need it. Today we're going to talk a little bit about just how we're helping customers with those challenges and demonstrate how that same experience looks in each of these various places. Slight differences, but the core value proposition, that core continuity of the experience remains the same, regardless of where those applications need to reside. And we're really enabling those customers to build using the same APIs, the same tooling, and write applications once and deploy everywhere. It's a common theme that I believe you'll continue to hear from folks across our hybrid space, both throughout the conference and the coming years. We're thinking about this as how do we provide a continuum of consistent cloud scale services to enable innovation, to enable builders and operators to operate the same way they can in the cloud. So if you think about that continuum that I just mentioned, it started with the regions and extends all the way out to the far edge, to those smart devices running IoT services, tools like FreeRTOS and Greengrass, nested within 5G networks on phones and other smart devices. Now, where it all started is the AWS Regions. And we're excited that we continue to have the most extensive global infrastructure with 30 regions and 96 availability zones today. Now, just as a reminder, a region for us consists of 3 or more availability zones. Each is a fully isolated, discrete data center, physically separated from the other availability zones within the regions. And those regions support more than 200 services that run on AWS. Now, this year, I'm excited to share that we recently announced the general availability of some new regions in the UAE, Switzerland, Spain, and Hyderabad as our second region in India. We've also announced our plans for 7 more AWS regions, including Australia, Canada, Israel, New Zealand, and Thailand. So the message here is we're not slowing down. We're continuing to extend beyond this. And we've gone even farther than these regions to bring our services and that approach closer to customers and users to places that require ultra-low latency. Many of our customers need local compute and storage farther away from the region than we're able to serve. So what local zones do is they extend the ability to use our compute into metro areas, metro centers, sometimes to bring it within the borders of a country where we might not have a region today. With local zones, we have 25 local zones that we've launched today, and we've announced 27 new international local zones where we bring our compute, storage, database, and other services close to those large industry centers where applications are being built and need to be maintained with low latency to that local user base. I'm also really excited that we just announced 4 new international local zones earlier this week, which extend local zones to customers in Buenos Aires, Copenhagen, Helsinki, and Muscat. That's 8 total international local zones, and we'll continue to deliver more through the rest of this year and into 2023. But we haven't stopped at the local zone level for those local metro workloads. We've also been partnering closely with 5G carriers who actually need to bring our compute into their network itself. And to better serve these workloads, we've introduced AWS wavelength zones, which is in effect a local zone embedded within the carrier network. And we've partnered with carriers including Verizon, Bell Canada in North America, Vodafone in Europe, KDDI in Japan, and SK Telecom in South Korea. But beyond the metro areas and the telco networks, we also have customer workloads that can't leave a physical data center, whether that's a data center with legacy hardware, monolithic applications, whether that's a factory floor because it's controlling robotics on an assembly line, whether they just need a local resource for whatever reason and can't use our facility. And that's where AWS Outposts come in, which are available in 73 countries and territories today. Outposts are a family of fully managed solutions which bring this very same AWS infrastructure and services to virtually any location that can support data center equipment. It could be a data center, could be a factory, it could be a garage, could be anywhere that you can provide power and a reliable network connection. And we also bring Outpost in both a 42U rack and a 1 and a 2U server. So not even, you no longer even need to support a full rack. You can come at a single server at a time. We can also extend those to multi-rack deployments. And with Outposts, the way to think about this is slightly different than the region and the local zones, is that customers have a hand in managing the capacity. That you come to us and size your capacity, order what you need. We build those racks specifically for you and deliver them, fully built, fully tested, and integrated into your data center. Roll them into place and connect it to the power and the network which you've made available to us, and provision that capacity for you. Using the AWS console, you'll immediately have access to that capacity as a private subnet within your EC2 console, and you can launch instances on that. Now this is an industry standard 42U rack. It's the very same racks that we use in our data centers. Fully assembled, there's no racking and stacking, there's no fussing with the cables, there's no worrying about the inside of the rack. That's part of the managed service that we provide with Outposts. It's quite simply a plug and play. We also bring a centralized, redundant power unit. As we've learned managing our data centers for a number of years now, power supplies are often the most common source of failure in servers. So we're able to decouple that from the servers themselves and provide resilient power in the rack. Also able to come out and service those servers, replace them as needed, and design and help you architect your application in a way such that it's resilient to a single server failure. Every component inside the rack that we provide to you has redundancy. So any failure, whether it's power, switches, or anything else, will not impact your workload. The servers are a little bit newer than the racks. We've gone even further and allowed customers to self-install with the racks. We send out a technician to roll that into place and make sure everything is working before our technicians depart your data center. These Outpost servers allow customers to bring those workloads even farther into places like retail stores, into smaller local distribution centers, sites out in the field where there's equipment. Maybe it's mining or manufacturing or drilling or a whole host of other applications. And again, have that consistent experience, the ability to build their applications and test in the cloud, not have to dedicate local capacity to test because it's the very same easy-to experience and easily deploy anywhere using CloudFormation, Terraform, or your tool of choice. We have the 1U server, which runs on a Graviton 2 processor, a C6GD-based instance type, and we have a 2U Intel-based server that's a C6ID instance type, which can easily be mounted in any rack that you provide, or even set on a table, a desk, tucked in closet, connected to power and network to run your local workloads. That provides a layer 2 connectivity for your local network, because on a single server, we don't in fact have a switch that we manage for you as we do in the racks. Now, I mentioned a good deal about the services that we bring locally. These are the services available today on AWS Outposts, as with local zones and wavelengths. These are the very same services, the very same APIs that you can use in the region. We have a variety of these services today, and we continue to listen to customers on how we prioritize the next set. This is not 200 services. It won't be 200 services in the near future. And while we will continue to innovate in this space, we also look to our Amazon partner network, and we have an Outpost Service Ready program with more than 70 partner solutions, which complement our own services. They provide two really helpful benefits to customers running workloads at the edge. One is they extend compatibility for customer applications that run on the region. For example, using DynamoDB, which is not available on Outposts, but our partner ScyllaDB provides a Dynamo API compatible NoSQL database solution that we've worked closely with them, tested in our Outpost test lab, and can run locally on the Outposts. They also provide the very nice continuity with existing customer edge applications. As we found, many of our partners our customers are using these same partner solutions on the commodity hardware stack that they operate today. And as much as consistency with the region is important, consistency with their customers' existing application stacks today helps ease that modernization and migration. We're continuing to iterate on those services and the features within each. We've spent a good part of the last year focused on these three primary areas: enhancing the availability, security, and compliance, simplifying management and scaling, which is particularly important now that we're 3 years into this business and we're seeing customer workloads grow and mature on Outposts, and also accelerating that cloud migration and modernization element. We recognize that the Outpost is often not the forever place for all of these workloads. It may be for some, and that's great. For others, they will move, whether it's to a new local zone in a new metro area or a new region as we build them, or perhaps as the applications modernize and become closer and closer to a microservices-based approach, where certain elements can be separated and moved into the region for those additional services and the efficiency and scalability, while keeping only the critical few locally, and allow customers to right-size those local deployments in a way that is best for their business technically and often financially as well. To go a little bit deeper on the availability, security, and compliance issues, We're really excited to bring placement groups to AWS Outposts earlier this year. And if you're familiar with the concept of our placement groups, spread and cluster in the region, we handle placement at the rack level, but many customers deploy just a single Outpost rack. So we brought a new granularity to our placement groups on Outposts to allow customers to actually specify placement at the host level, making sure that they're going to design applications, and we'll deploy them we'll deploy those for them on separate physical hosts, again to add resilience to a physical host failure. We've also addressed some networking challenges that we've seen customers work through, particularly with the ingress routing, and offered local gateway ingress routing to allow them to fine-tune both the security and network management, very much the same that customers can in the region. Another really exciting thing that we brought was local clusters for Amazon EKS on Outposts. If you're familiar with Kubernetes, and I'll go a little bit deeper in a bit, the Kubernetes worker node and the control node need to be in communication with each other constantly, but when they're disconnected for more than 6 or so minutes, the control node marks that as degraded. So we actually took the local cluster, the control node, and moved it to a cluster of instances locally on the Outpost to make those deployments and those customers running EKS more resilient to temporary network flap and disconnectivity issues, and to make sure that their applications were not impacted by those types of network environments. We also brought multi-availability zone RDS to Outposts. Before a few months ago, RDS on Outposts was a single instance deployment. As many of you know, that's dev test in database space. No one's running production on a single instance. So now we can have customers deploy multiple Outposts home to 2 different availability zones, and RDS will manage a highly available database across those 2, much like they do in region. Outpost is also now FedRAMP moderate authorized for our domestic regions in the United States, and we've brought our S3 on Outposts into our GovCloud regions for public sector workloads. I want to go a little bit deeper on what we did with EKS and the local cluster. As I mentioned, we took that Kubernetes control plane and we took it out of the region and brought it onto the Outpost. Now what that does is, as you may be familiar, Kubernetes, when that connection is lost, it fails open. So the workload continues, and if it does complete, things are fine. But if that network is disconnected between the Outpost and the home region for more than 6 or so minutes, that worker node is marked as degraded. And when the connection is reestablished, if the worker node has not completed its task, it's terminated, which impacts the customer application in a quite unpredictable way as you work through these short and temporary network issues. So now with the Kubernetes control plane locally, that connection is no longer dependent on the connection to the home region, and customers can reason on their Kubernetes experience in a much more straightforward way. To just go a little bit deeper, this will occupy some EC2 capacity on the Outpost, so it's something to account for when you're thinking about sizing your workload. But the shift of that management into the Outpost itself provides some important resiliency, and that's something you'll see us continue to focus on in the edge. How can we take the core and most critical capability and bring it locally onto the Outpost to make it more resilient and make it easier for your builders to reason on as they build their applications and understand what the impact of a change in the network conditions will result in for your application experience. To go a little bit deeper on the multi-outpost RDS deployments, as I mentioned, this requires 2 outposts. Outposts are homed to an availability zone in the region. We actually treat those servers just as if they were part of that availability zone. They'll show up in your EC2 console as a private subnet for your accounts within that zone. So when you have 2 outposts homed to 2 different zones, you've effectively extended our well-architected guidance down to the edge, and RDS can now deploy on both. It is highly dependent on the connection that you manage between those 2 outposts. It's a really important point. With Outpost, you're managing that local network. So if you have a high fidelity connection between those 2 racks in your data center, RDS can handle less than 5-minute round trip time between the 2, and it will synchronize that data. And in the event of a failure of any type on the primary node, it will automatically fail over, promote the passive node to active. You'll continue to access your database. And when whatever the issue is on the formerly primary node. Once that has been resolved, RDS will rebalance and return to its resilient state. I should mention RDS is built on the Elastic Block Store, or EBS. So that data is written to EBS, it's replicated, and before we go and confirm that the write has occurred, RDS will actually confirm that the write has occurred on both of those outposts. So when you get the confirmation from RDS, you can be assured that that resilient architecture is in place. Now moving on to management and scaling, as customers get deeper in their workloads with Outpost, they're scaling up, they're scaling out, they're increasing the capacity that they're using, and with that additional capacity, it brings a layer of complexity managing that. One of the issues that we've talked through again on the networking side is access to that increasing pool of EC2 instances and resources on the Outpost. We earlier this year launched support for direct VPC routing on the Outpost. This allows you to access those EC2 instances using your VPC IP address from other devices on your local network, no longer having to use a customer-owned and managed IP address. We've also released support for storage auto-scaling for RDS on Outpost. You can specify your maximum cluster size, and RDS will handle the scaling for you. We've also invested in some improvements to S3, our local object storage on the Outpost. Introduced some storage management capabilities with lifecycle actions and filters, just the same as you can use with S3 in the region, and also support for object Outpost access point aliases, which allow you to really get fine-grained in your permissions and control of your objects and buckets within S3 locally, again, just the same way that you can in the region. And that's, again, the common theme is that continuity of the customer experience. We've also brought pre-signed URLs and private link management for your S3 buckets. To go a little bit deeper on that direct VPC routing, it's really in a sense that we are doing an IP mapping for you, and if you want to call that VPC IP address, we will route that traffic directly onto the Outpost for you and give you access to those resources. This works much the same as it does with the VPC in region. So again, we're thinking about how do we extend that networking experience that is familiar in the region. And the idea behind this is to give builders that same experience. So when they're writing application, when they're thinking about their networking constructs, the parity and consistency is one of the core tenets as we build and develop at the edge. And then the last piece is the acceleration of migration. And really, there's a modernization piece underpinning this. We've brought dedicated hosts to Outposts, which have been a really helpful tool as customers manage their own third-party license requirements and compliance. We've extended support for our new enterprise on-ramp program. With Outposts, we do ask customers have AWS enterprise support, and we've learned that some of these customers who are new to AWS look at enterprise support as an early days financial challenge. The on-ramp program allows customers to reduce that support cost by 66%. And have that same experience with the dedicated technical account manager and the quick response time and folks who are deeply familiar with their applications, their technical stack, and the Outpost service, the underlying technology as well. And we've also introduced a number of AWS backup capabilities to just help make it easier for customers to back up and archive and keep their data safe while using Outposts. Now with all that said, I want to introduce Jai Kumar to talk a little bit about just how First Abu Dhabi Bank is using Outposts in their facilities. Thanks.
Thank you, Rob. Good morning, everyone. So I'm Jai Kumar, Head of Service in Cloud Platform in First Abu Dhabi Bank. In the next 10 minutes, myself and my colleague Sandy are going to take over what the use case and how we got the successful business requirement from the Outpost implementation. So before we begin, just a brief intro about the First Abu Dhabi Bank. In short, it's FAB. We are the largest bank in UAE region, and also we are one of the world's largest and the safest bank institute. And headquarters in Abu Dhabi, and we have an operation across the 20 different countries. With almost total asset value of close to over $312 billion US. And we have actively 3 million customers across the various customer banking segment, which include the consumer, corporate, private investment in various countries. So what's our requirement? Just like all the other bank, we want to transform the user experience of our customer. Just like in many other countries, one of the key most important requirement is data residency. So we cannot take the data outside the UAE and we cannot process or store outside. That's the most mandatory requirement. And also as we have the many transformation journey, just one of them we want to give an example is among them, we want to give the seamless customer experience. It's a straight through account processing where the customer can open the account with the activated bank account and also deliver the credit card to his mobile phone within less than 10 minutes. So this is what kind of the requirement we have as a part of the transformation. So how we achieved it, the solutioning, what we did. So we leveraged the AWS Outpost because one of the primary reason, as Rob mentioned, we want to go with the more modernized container-based architecture. We don't want to use the typical 3-tier architecture, etc. And as much as possible, we want to go with the managed services for all our business solution. So to avoid that and isolate, not to disturb the development team and let them concentrate on the actual functionality delivery rather than managing the infrastructure. And this comes hand in hand, Output support the complete requirement of your requirement. All it says, previously I mentioned, all the data are processed and stored within our data center. Okay, so it's never leave our data center. And also, as a customer responsibility, we need to manage the business continuity and highly resilient. So we have set up the multiple outposts in our 2 different data centers with as per our custom requirement as well as the power requirement. So it's in short, in the management console, it's going to be another 2 availability zones. So it gives the full power for the application development team there, how they want to deploy their application, either active-active or active-passive, just similar to your public region. Okay. And what is the outcome? So we able to achieve over the 50% reduction in the faster to the time to market. This is simply because in previous, the legacy way of working, always the pipeline get chocked, because the more the functionality, the number of team work in parallel was blocked because that it's the single infrastructure teams, they need to deliver that to fulfill the requirement or to make it go into the live. Whereas with this model, we leverage the Bahrain for all our development and testing environment. So you can do all your innovation lab and fail fast and get it done faster. And then the same thing, same code, you can quickly move it to the Outpost as the production environment. So that's how we are able to reduce the time to market by running the many parallel teams in quickly. And also more than 60% of the increase in the developer and infrastructure resource. So why it is it's this whatever the development or the infrastructure code, we build it in the development or in the test environment. The same can be taken and replicated in the Outpost in a fraction of a minute, as it is a click of button. So at the same time, these are in addition to that, whatever the public region benefit you get, the cloud watch, container security, all those things you can leverage here it's also. So that way, our productivity also increase and we are able to achieve the faster time to market. So you all wondering how our setup and how the architecture has been built. So for that, quickly I will introduce. Santiago will take that in detail about that setup.
Thanks, Jay. Hello. So let me talk through exactly how we actually have deployed this architecture. So on the right, on your right-hand side, my left-hand side, you have our data centers. So what we did is within the UAE, we have actually have more than 2, but for this particular setup, we're actually using 2 of our data centers. One's a production data center, and the other one is also is our disaster recovery data center. So what we did is we co-located outposts, several outpost racks within each one of those data centers. And then first thing that was important for us was to make sure that there is highly available redundant connectivity from the outpost, in fact, from the data center back to the region. So what we have is we have redundant, at least we have 2 direct connect links from each one of the data centers back to the AWS region in Bahrain. As Jay referred to, from the first data center, that maps back to one availability zone in the region, and from the second data center, we map back to a different availability zone into the region. What was also very important for us was to make sure that between those two data centers, we had a highly available and sizably appropriately data center interconnect links. Because as you're going to see as I go into the architecture of the application itself, we make usage of that link to replicate data between the two sites. Let me give you a walkthrough here of one particular challenge that we address and what we find to be one of the really powerful characteristics of Outpost, which is the ability to combine local services. So some of those services that Rob was talking about. In this particular case, we're talking about RDS, EC2, of course, EBS running here, S3 as well. And also, I didn't represent here, but there are all the application layers running on containers on EKS. And the ability to combine those local services with the regional services, it's really powerful. So let me give you an example. Here we actually had our customer onboarding microservice that stored data on RDS, actually RDS on Postgres. And we had the requirement that even not only the data had to be stored on RDS, but also the backup itself had to remain within the UAE, in the country itself. So we look at that problem and we start thinking about, hey, in a traditional way, would we run some scripts? We'd have to develop some cron jobs. How do we manage failure? All of those types of issues that we'd have to deal with if we were to do it ourselves. And then we start thinking about, can we actually combine the power of the region-based services with Outpost to actually build a way that's repeatable, automated, and can also handle failures and alert us. And that's what we did. So we took CloudWatch events. We set it up in a way that it runs periodically on a schedule basis. It triggers Systems Manager, SSM, which it then actually triggers a run command that's actually running here on a local EC2 instance that executes effectively a dump of the database on a scheduled basis, on a periodic basis. It then scopes that data across to another EC2 instance running on the second Outpost, and then issue another command to actually copy the data into S3 that's on the second Outpost. So that allowed us to do this automated backup across Outposts. And the beauty of that is that also if something goes wrong, for whatever reason, that particular run command fails, we were able to catch that through CloudWatch, look at the logs, see the metrics, generate the alert, and use SNS to go and send an email and SMS to our ops teams. So hopefully this gives an idea on the power of being able to combine the region-based services with some of the local services. So in terms of what that usage of Outpost has enabled us, and we've been using for nearly 18 months now, first thing is it's enabled us to adopt containerized workloads. So we heavily use it of EKS on Outpost. It's also allowed us, from a business point of view, to build pretty much all of our new digital journeys. We built on this platform, such as customer onboarding for our consumer banking, multi-account management, remote check deposit for our corporate customers as well. Third point is, it's very important for us to leverage Outpost to help our engineers, developers, and infra teams to become familiar with AWS ahead of AWS having a region in the UAE. AWS just launched a couple of months ago a region in the UAE. We've been using Outpost for over 18 months now. And we heavily use it of the managed service. In fact, we prefer the managed service across EKS, RDS, of course, we run EC2 as well, the load balancer, S3, and so on. So with that, Rob, hand over back to you.
Thanks, Santiago, Jaya. Always exciting to hear a little bit about how customers are using our services. I want to get a little bit deeper under the hood and talk a bit more about the Outpost rack and the service and how we've built this infrastructure itself. I should add that the technology that we use to build Outposts is the very same technology that we use to stand up those local zones, the wavelength zones, for much of that work at the edge. And when we think about building that, we think about building all the benefits, all the resiliency and scalability from the region, but bringing it down to a smaller scale. So it's the sameness, the consistency is a core tenet that's important. It's the same control plane. It's the same Nitro hardware. It's the same Nitro hypervisor. We use the same pipelines to update and to maintain this, both the hardware and the software and the firmware, to make that experience consistent. Going inside the rack, we have 2 network patch panels at the top of the rack, again, back with that redundancy theme. This is all pre-built, pre-tested at our manufacturing facilities. We build these racks on the very same manufacturing lines that we build our racks in the region. We can turn these out at scale. And one of the things that helps us quite a bit is the consistency in the hardware allows us the benefits of cloud scale, even when customers just need a single rack, both the economic and the manufacturing tailwinds and all of that. Then we have the hosts. There's a power shelf in the middle, along with some network switches. I think I mentioned power earlier, that we've identified power is one of the common failure scenarios. So we've decoupled power from the server. We've brought that redundant centralized power conversion unit. We actually don't include any batteries in that because we appreciate that batteries in some customer data centers introduces a layer of complexity. So you of course are free to use any type of battery backup devices that might make sense for your workload outside the rack. You get that same network experiences that you do with an EC2, the 25 gigabit connectivity. Back to the power, this is a photo of the back of a rack in one of our office labs. We offer those redundant power connections right there for you. We recommend that you use redundant power sources without a single point of failure. So whether there's 2 separate power feeds, whether you have a generator, a battery backup system, whatever the case may be, if you have 2 constant feeds, a failure in one will not impact the rack. The rack can and will operate with one power supply, although you don't have the same resilience there. I think I see a hand there. Go ahead. Yeah, great question. So the storage, everything in the rack is built on EC2. So our storage services are stood up on some of those servers in the rack that will not be accessible to you and will be managed by our storage services, whether that's EBS or S3. So in a sense, we will share some of that compute infrastructure. Some of that will be yours. Some of that will be ours, used by AWS services on the rack. And that's actually a great point. It's a key distinction when you think about services higher up the stack, such as ALB, our application load balancer, or RDS, our managed SQL database. In the region, when you purchase those services from us, we sell you the managed service and the compute that it runs on. On the Outpost, it runs on compute that you've provisioned. So when you size the Outpost, you include the compute required for both your applications and our applications. When we charge you for those services, we just charge you a service management fee because you've already paid for the compute as part of your Outpost and included that for the service. I guess similar with the networking, we have 2 separate network connections, recommend independent paths. So a fiber cut on one leaves you with another resilient network connection. But the heart of this is really the AWS Nitro System. And I wanted to take a minute to talk a bit about the Nitro System because this is what enabled us to take our technology, to take those same servers out of the data center and bring them to the edge. And the first piece of the Nitro System, it's really a 3-part deep dive here, are the Nitro cards themselves. These have a custom-built ASIC built by AWS that enables really efficient, high-performance I/O virtualization. This runs our VPC networking, it runs our EBS storage, it runs our instance storage, and we're able to do full line rate encryption because of the technology that these Nitro cards bring. The next piece is the Nitro security chip itself. Security is always job 0 at AWS. And one of the things that we really focused on when building Nitro was raising the security bar as high as possible. So with this Nitro security chip that we've built, we can really deeply trust this hardware throughout the entire system and its entire life cycle. It gives us a significant advantage over off-the-shelf motherboards and protects those hardware resources as we think about constantly improving and building that trust model. And once we put the Nitro card and the security chip in place, we were able to take a look at the hypervisor, the real core of the virtualization there, and realize that we could simplify it an awful lot because of the functionality that the Nitro cards provided. So we did just that. We removed the network stack. We really just needed memory and CPU allocation. And that Nitro hypervisor is so tightly coupled with the Nitro card itself that that's really all we communicate with. And it's the Nitro card itself that actually interfaces with that compute and storage on the host itself. What's really exciting with Outposts is this is the first time that we can take all of that innovation and bring it into your data center and extend those benefits for you. And the heart of it on the security side is the Nitro security key. I actually brought one here with me. We've got an Outpost on the expo floor, one in the executive briefing center over in the Venetian. Really tiny, give or take the size of a business card. And much of this is a metal enclosure to allow it to connect to the rack. But if you look at one of our Outpost racks, there's one of these, and there's a very small chip inside here that connects to the front of every server. This is a huge piece of not just our security architecture, but also our sustainability efforts here. Because all data is encrypted at rest and in transit with the Nitro system. So what we've done is we've extended the security key into a piece of silicon in this little enclosure. And you can see, maybe you can't, I'm happy to show folks after, there's a little sticker that covers a small Phillips head screw here. And that Phillips head screw is designed to physically destroy this small circuit board. So before we take a server out, if we need to replace the server, if we're decommissioning the Outpost for any reason, we pull this out and we'll hand it to your engineer on site. We're happy to handle it for you. Some customers like to twist the screw themselves. That destruction is the equivalent of shredding your hard drive, but the hard drive's not shredded. All that associated bad environmental waste is not generated. Any data that remains on that, of course we recommend you go ahead and remove everything, is now entirely inaccessible. It's a really phenomenal innovation, and it solves so many logistics challenges, as I mentioned, a tailwind on sustainability, and really a key part of the way we raise the bar on security. That's part of the innovation on Outpost that you'll see continue to come back upstream into AWS data centers. It's already present in local zones, and even see that come up into our regions in the future. Really, really exciting what we've done here, and pretty elegant as a hardware solution as well. Now, bring it all together. I told you a little bit about Outpost, what it does. How does the rack work? How do you think about that? I've mentioned it's an extension of the region. It really is. If you think about this as a generic AWS region with multiple availability zones, you just need a connection to your data center. And maybe your data center is in a collocation facility that also happens to have an AWS point of presence, maybe a direct connect location. That last mile connection could be as simple as the cable from the meet me room in the direct connect point of presence to your cage in that facility. Or it could run for miles or kilometers across local metro fiber to an office building, to a manufacturing facility, whatever the case may be. That's the beauty of Outpost. It allows you the flexibility to connect back to the AWS region wherever, whenever, and however works the best for you. Now that's probably dependent on your business, it's dependent on your workload, it's dependent on your availability needs, and we've gone in the traditional AWS way down to the building block culture to give you options and dials and levers to design a solution that meets your needs, both the business needs, the technical needs, and the financial needs. Fundamentally, using that Nitro system and the Nitro security key, it allows us to think about the servers on your Outpost just as if they were part of that physical availability zone, and to use them, to manage them, to deploy our code to them in the same way. In fact, when we deploy code to our regions, we have a highly mechanized system where we slowly deploy and we test. We never deploy to more than one availability zone in a region on the same day. We actually add Outposts in our edge zones at the end behind the region, which is very deliberate. We'll make sure the code has a chance to bake, if you will, through the region availability zones. We'll deploy in a local zone first, where we have additional capacity and better capability to manage any issues. And once we've deployed our code through the entire region, through the entire availability zone in the region, through any local zone which may be connected, then we'll continue that deployment to the outposts, making sure that your workloads where you have the smallest pool of capacity are going to have every chance for us to identify an issue, roll back, and make sure that doesn't impact availability or your workload. Networking with the AWS racks, again, it's the Outpost racks, very similar to networking in the region. This is an extension of your VPC. We've introduced 2 new networking constructs with Outpost. One is called the service link, which is the connection back to our home region. The other is the local gateway on the racks. We call this the LNI, or the local network interface on the Outpost servers. As I mentioned, that's just a functional difference of us not having a switch there. And you can work with any workloads locally on your region through that local gateway. I should add that an important distinction between Outposts and local zones is the placement of the AWS network backbone, our border, if you will. That local zones are inside our border. Outposts are outside of our border. The important thing there is that we charge for data transfer outbound across that border. So if you have workloads running on the Outpost and a lot of ingress and egress to another system, for example, on your local network, that's all free traffic because it's on your network. The egress point for data to your Outpost are the AMIs coming from the region to run on your Outpost, which in most cases are not launched quite as frequently as other chatty applications may be traversing that local gateway. Now, when you're in a local zone, much like the region, those AMIs, you can launch them all day because they never leave, but any data that goes out is something to be thoughtful about. Sometimes that can be an important piece to think about when you're choosing, is a local zone or an Outpost right for me? And again, in the early days, as these workloads migrate and modernize, we want to find the right solution for you now, understanding that the right solution for you later might look different, but if you're built on our AWS APIs, you can easily shift and deploy that application when it makes sense. These are not one-way door decisions. Just to spend a minute on ordering and installation, when you think about sizing the workload, you do need to think a little bit more about capacity management than ever before. If you're managing on-prem workloads, this is not a new concept. If your team is cloud first or cloud forward, this is a different mental model. We can expand, but we can't expand in minutes. Expansion is measured in days or weeks. We can bring new servers, we can bring new racks, et cetera. So what you do first is you go to the AWS console. You can also do this through our APIs, and you create a site. You tell us where this is going to be. Whether it's a rack or a server, we need to know where it is. We need to know what your power requirements are, what your network configuration is, both the bandwidth and the technical specs and the physical port details. We make sure that your data center floor can support the weight. Some of these fully loaded Outpost racks can exceed 1,700 pounds. We've worked with customers who need a little extra bracing. We check the doorways, make sure you have the right height and clearance in the elevators and things like that. Since it does come fully assembled, these things are not too easy to tilt. But we have a terrific team of delivery technicians that have pulled off a few installations that I would say are nothing short of small miracles, getting racks into facilities where they first looked like they didn't fit. Now, once that site is created and we have enough, we actually send a team out to do a pre-visit. Some of that's virtual, some of that's a physical test. We test the network, we look at the power, that's where we check all those details. You go ahead and select your Outpost. You size it. You tell us how many instances you need, how many vCPUs. Do you need C, M, R, I, G type instances? We help build for resiliency. As I mentioned, we provide extra of every part available on the Outpost except the compute, because that's where we partner with you to size it. So we recommend additional instances of every family. Now, for example, if you're running on C5s and R5s, you might decide that the economics make sense for you to have a single additional R5 host, and that you can make your applications work such that if one of those C5 hosts failed, that can run on an extra R5 for a day or two while we troubleshoot or replace the host if we need to. You might have something that's sufficiently critical that you want to have an extra C and an extra R, and we can work with you on both the technical and the economic aspects there. Now, once you've selected that and ordered the Outpost, we go ahead and make that, custom build the rack for you, tested, transported to your site. rolled into place, connect to power, connect to network. The operations techs make sure everything is safely installed. We brace it if it's in a site where we need to think about things like earthquakes or other natural disasters to make sure it's safe for everybody involved. And then they send a message back to our systems in the region, which bring that up in the same way as if we just rolled a rack into our data centers. For the smaller servers, it's even easier. We're really excited that these are self-installs. So we're just going to send a box. You tell us where it needs to be. We can ship it somewhere else. Sometimes people don't like to receive packages in the facilities. As long as we know where it's ultimately running, that's all that really matters to us. You unbox this, and we're going to walk you through a video tutorial to spin everything up yourself, and again, send a signal back to our systems, knowing that this is in its final destination, it's powered up, it's connected to the network, your network environment is static, and we're going to go ahead and provision that hardware for you, and that just let you know when you're ready to run instances. So I want to end with a couple of additional customer use cases. This is what's most exciting about the Edge business for us, frankly. If anyone caught Adam Solipsky's keynote yesterday or Dave Brown's compute leadership session? Sorry, let's take a question first.
Can we extend the storage capacity, the local capacity, and connect the local storage to the...
Absolutely. Across the network, you won't have physical access to any ports on the Outpost itself, but if you have a local storage device, and we in fact see many customers doing this, data has gravity. Storage devices are a more complicated migration. So we've in fact tested with a number of the leading storage providers, folks like Pure Storage and Quantum and others, and confirmed that you can access your storage locally across the local gateway from those EC2 instances on the Outpost.
Does this apply for both A1U and...
Absolutely, for the racks and the servers. It's incredibly important on the servers, because on the servers we offer instance storage, but we don't offer elastic block storage or S3 because the footprint is so small. So the ability to use a small persistent storage device locally on your network next to that server is really important for anybody that needs to have something that is storage that is decoupled from the instances themselves.
How about directly connected?
Yeah, again, across the network, the accessing storage across the network.
Means you cannot just directly connect.
That's correct. Not a direct connection, but if you can orchestrate across the network, you'll have direct access to the storage.
So if we connect, sorry,
Yeah,
if we connect to the network, right, so we will be getting that optimized network connection?
absolutely. You will own the network. We can help you with that. We've got some specialist professional services resources and Amazon managed services, but we've tuned that network connection for a number of customers, and found for the majority of workloads, we can optimize that storage access across the network. Yeah, I'd be happy to talk a little more. Yeah, absolutely. Anyway, back to NASDAQ, we had a little Q&A session that was fantastic in Dave Brown's compute leadership session yesterday. NASDAQ has been partnering with us for years to modernize their applications to become a cloud-first company. But one of the biggest technical challenges they had was moving their markets to the cloud. They just have such incredibly low latency requirements. And we announced a partnership with them last year at reInvent, and here we are 12 months later, and they're underway in migrating their first domestic exchange to Outposts. Their symbols trading on Outposts today in the New York metro area. Incredibly exciting. We worked with them to really optimize how the application was built and get that high performance, multicast network experience they need, and to satisfy all of their incredibly specific regulations. We've also architected for very high availability and resilience, additional servers, additional capacity, additional racks, so that they can withstand failures of any type. One exercise that we went through with them, which I found incredibly useful, was we actually wrote a document identifying the various failure scenarios, quantifying what that would mean for their business, and then proposing a number of options on how we should address that in the architectural build, so that we all were on the same page along the lines of, what is this problem? How does it play out? How are we going to solve it? how do the economics feed back, and does it make sense? I highly recommend that type of exercise for anyone who's thinking about building on Outposts, and we've got a team of folks who can help you do that. Don't feel like you need to do that on your own. Really excited to see what NASDAQ continues to do in the coming months and years. Another great example is Inmarsat. They're a global mobile satellite communications company, and they provide critical voice and data communications. Now, they're a modern company. The majority of their workloads have moved to AWS into the regions, but they have some hyper-local workloads with very low latency requirements. Their billing system is a great example of that just needs to move really quickly based on the traffic. We've deployed Outposts for Inmarsat. They have an internal target to keep latency at under 2 milliseconds. With building on Outposts, they were able to achieve 1.2 milliseconds. So nearly 50% lower than their desired target, but allowing their developers and their application builders to use the same tools that they're using for all of the cloud-based tooling that they have today. Athena Health is another example. They're a modern cloud-based electronic health records company. They provide network-enabled services. They're underway in a modernization journey, building new features, moving to the cloud. And Outposts have been a great way for them to accelerate, bringing the AWS APIs on premises, looking at those monolithic systems. It can be daunting and overwhelming to think about, how do I move these? Where are the natural breakpoints? When you bring the EC2 and EBS APIs locally, developers can experiment. They can play around very quickly, very efficiently. They can understand what works and what breaks. And what we see is the natural separation points emerge faster than we ever expected. And it allows them to modernize on those APIs and then to move piece by piece as it makes sense. I expect in the fullness of time, Athena Health will not use Outposts forever. That's okay. As an Outpost business owner, you might think small that that's disappointing, but it's actually really exciting, both for Athena Health, other customers, and for AWS as a whole, that we're accelerating that modernization, we're accelerating that migration. It may happen in half the time that it would have if they didn't have the ability to extend our services on-prem. And I saved an exciting one for the end. Amazon.com is deploying Outposts in our Amazon fulfillment centers. We've got a little video. We unfortunately couldn't have our colleagues join us to talk directly from Meyer, Gary, and Sophie about just what they're doing with Outposts in the fulfillment centers today.
Hi, I'm Gary Walensky. I'm a solutions architect here at AWS. In my role as a solutions architect, I support lots of customers, especially Amazon, one of our largest customers. Fortunately today, I'm joined by one of my customers, my colleague, Mayur.
Thank you, Gary. It's great to be here at one of the Amazon largest fulfillment centers. I am Mayur Nimade. I'm a senior software engineer at Amazon Robotics. My day-to-day job involves working with these bots. My teams are responsible for control and coordinating these drive units, so that's a safer operation for everybody.
It's really great to be here in the center of the action. Mayur, can you tell us a little bit about this operation? I'm really excited to learn more about the technology that's really enabling Amazon to deliver on that same day or next day promise.
Definitely. So we are at a pretty typical automated fulfillment center. The robotic drive units are part of our automated storage and retrieval system, also commonly referred to as ASRS in the industry.
The automated storage and retrieval system. Can you explain what that is?
Sure. So a lot of things need to happen before we actually ship a package to a customer. The product gets delivered from supplier in bulk. We basically unpack it and store it on the shelf units. We call this process as stow. When a customer order comes in, we basically pull the items from the shelf, and we call this process as pick. The storage area basically spans the size of a couple of football fields, so you can imagine the amount of walking our associates would have to do for this pick and store processes. In any given shift, 10 or more miles was not unheard of. It's great for closing your Apple rings, but very hard for the associates.
That's a lot of walking. So I'm wondering, I know that Amazon has made a commitment to be Earth's best place to work and the safest place to work. And I'm just wondering what we're doing to help the associates with this.
That's a very good question. So that's where our ASRS system comes into the picture. So basically, instead of having the associates doing all the walking, we use the rotary drive units to bring the shelves back to the associates. We kind of reverse the whole thing. So if we are not treating the shelf as stationary anymore and associates having to do the walking, we reverse the whole thing.
So how do the drive units know where to go, what shelves to pick up?
Well, that's our entire system. It's a complex system with a lot of moving parts. But basically, whenever a customer places an order, we get an itemized list of the products in that order. We have an inventory system that associates every single SKU or like item on a pod to a shelf. We also have a system that tracks the positions of all these pods. What the system does is basically enqueues a task for a drive unit. The task itself has coordinates of where the shelf is located and where the associate is, where the payload, the shelf needs to get delivered, right? So it's basically the start and end location. But as we're driving, you know that destination is only part of the equation. You also need to know how to get there in a most efficient and optimized manner.
But the drive units appear to be moving so smoothly.
Drive is moving, it's reading the pre-rituals, recording its position, the system evaluating what the next steps are, as well as like reserving the space in advance and communicating it back to the drive. All this needs to happen within a fraction of a second, which results in the smooth and fluid motion that you see on the floor. This entire process is kind of repeated hundreds of times any given minute.
It really is mesmerizing to see all these robotic units moving perfectly synchronized. And I know it's kind of hard to kind of orchestrate, right? Thousands of devices. I know we have a really high bar for safety. And I'm just wondering kind of what is that latency tolerance in this kind of environment?
You're right. We absolutely require very low latency to keep the floor functional. Our customer promise of next day and sub same day delivery drives everything that we do here. So what that means is every millisecond between when an order is placed to the time it arrives at the customer doorstep matters. We adopted AWS Outposts, right? With AWS Outposts, you get AWS right at the edge, and right here in the fulfillment center, right? So how does that happen? Basically, we get best of both worlds. We have local low latency compute here, and you get all the bells and whistles with AWS, right? For example, you get VPCs, you get APIs, you also get the ability to have the same set of processes that you use for deployment in the region, as well as local here in the HC. My hope is that others can learn from the experience that we have had from running this robotic drive units in the Amazon Fulfillment Center over the last 10 years.
With the practical knowledge that we're getting from using AWS Outposts in a robotics-heavy environment like this is going to be very, very valuable to our customers. Right. Thanks, guys.
I know we're a minute over. Thanks, everyone. Appreciate the time. Happy to take some questions in the hallway. Want to thank our Edge customers for trusting us with their workloads. And also just mention that we've got some really cool stuff on the expo floor, including the free throw contest with some AI running out of the Las Vegas local zone, the free kick challenge outside of Caesars, and Outpost racks and servers all over to take a look at. Thanks so much.